The bullet stops in this amount of time. So I'm thinking, we know that the final velocity of the bullet is 0. So I'm thinking v squared is equal to v0 squared plus 2ax. Wait, did they tell us how fast it goes?
Yes.
400 meters per second? Okay, bonus. So then we get and f sub f. If we look at the bullet as it goes through the wood, I don't know, whatever, it's supposed to be a bullet. As it's going through the wood, right, the forces that are reacting, it's just f sub f. So f sub f is equal to ma. Did they give us the mass of the bullet?
10. Yes.
See, this is why you're supposed to write all the givens down. Anyways, so then if we can get A, we can have M. So then A is going to equal v squared minus v0 squared all over 2x. Of course, v squared is 0, right? So that's going to be
Negative 66,006.
so negative 6.67 times 10 to the negative. Is it 5? Is it 600,000?
No, 666,000.
Yeah, so to the 5th, right? So 6.67 times 10 to the 5th?
Yes.
Okay. And then we can multiply that by 0.01. So we get the force is negative 6.67 times 10 to the 3rd newtons. Because you have to convert to kilograms, right? And then you know the time, right? So this is, again, the easiest way, I would think, is V0 plus AT. So T, is this recording? Yeah, is equal to V minus V0 over A. Again, V being that, so negative 400 divided by negative 6.67 times 10 to the 5th.
600 micros.
Okay, so 600 microseconds. Sorry. So fast. There are 600 microseconds. And then the question is, what is this graph going to look like? This is the graph of the v versus t. We're assuming that this acceleration is constant, right? And if the acceleration is constant, what should the change in velocity look like? Okay. The question is, should it go like this or like this? Oh, or like this. How's that? There you go. A, B, or C. It's obvious it's negative, right? So it's got to have that or C. I always do that. I always say there is no acceleration. So rated up to some velocity. We're assuming that acceleration was constant. Then it went here. Oh, I can't get it over there. Well, actually, we don't know what's going on there. We don't know what's going on. Okay. I don't know. That's what they told me. Well, if we look at this, this is 4 times 10 to the 2 squared. So that's going to give us times 10 to the 4th divided by 0.02. No, I'm sorry, x, 0.24. 0.24. So it's basically like 1/4 on the bottom. So you multiply the top by 4. Right? So you get 1.6 or 1.6 times 10 to the 4th times 4. And that gives you 64 times 10 to the 5th. So then this is a reasonable approximation. I mean, that's a reasonable approximation. This is a reasonable answer. So most people, good, God. Most people said B. Here we go. If, let me see, let me make, what does the exact, what is A? You take the derivative of this function, like whatever, y is negative 2x or something, you get negative 2. What does the derivative of that look like, assuming it's a simple parabolic function?
It's a diagonal.
Okay, is it going to go like this, right? Yeah, so it's going to go like that. Now, what are we assuming based on this? Because what have we calculated? Yeah, we've calculated the average acceleration. We do not know this. Maybe it is, but we don't know that. All we know is that our calculations give us an average acceleration of this. So the answer is B. So the whole thing, when this thing got fired, acceleration was exerted on the bullet. In reality, this acceleration, this is probably like this. Because the explosion inside as volume becomes greater, the force exerted by the gas becomes less. Whatever, don't worry about it. Do you get the two lines?
Okay.
Just, all right? And